Today's topic is local linearity and differentials. All of our examples are going to come off of your homework worksheet for today. We're going to start with problem number 6 off of the worksheet. The instructions tell you to find f prime of x, which would be the derivative of f of x, and you're given this function, f of x equals x plus 3 times x plus 1 divided by x minus 1. And then you're also supposed to find the tangent line, the equation for the tangent line to the graph of this function at x equals a. And they tell you here a is going to equal -2. So the first thing we need to do is to find the derivative of this function. So we're going to have to use the quotient rule. So the bottom times the derivative of the top. Hang on. If we're going to take the derivative of the top, let's go ahead and FOIL that out first. So f of x would equal x squared plus 4x plus 3 over x minus 1. Now let's take the derivative. Bottom function times the derivative of the top, which would be 2x plus 4, minus top function times the derivative of the bottom, all over the bottom squared. And then this would probably be easier to use if we simplified it. So this would be 2x squared plus 2x minus 4 minus x squared minus 4x minus 3. Double checking my math here. Okay. All over x minus 1 squared. You could FOIL that out, but that's not really going to make it a whole lot simpler for us. F prime of x equals, that numerator would come to x squared minus 2x minus 7 over x minus 1 squared. Alright, so there's our derivative. That's the first part of the answer. Now we're going to find the equation of the tangent line at a equals -2. So I want to figure out what f prime of -2 is by plugging -2 in for x. Okay, so let's see. On the numerator, this is a minus. Okay, that should be 1/9 on the denominator. Okay, so that is going to be the slope of my tangent line. When I plug in that x value to the derivative, that's going to tell me what the slope is. Now, to write the equation of the tangent line, I'm also going to need a point. Now, the x-coordinate of that point is going to be -2, but I need a y-coordinate that corresponds to it, so I'm going to figure out what f of -2 is. This is going back to the original equation up here. So -2 plus 3 times -2 plus 1, all divided by -2 minus 1, will give me a -1 over -3, so that's just going to be 1/3. So that's what the y value for my point is. So I have a slope of 1/9 and a point, a coordinate pair, of -2 1/3. So now I'm ready to write my equation in point slope form, which would be y minus 1/3 equals 1/9 times x plus 2. If you wanted to distribute that and add 1/3 to both sides to get it into slope-intercept form, that'd be y equals 1/9 x plus 5/9. That's up to you. I think the answer key is going to have answers in slope-intercept form, although the AP exam accepts it either way. So that's whether you want to get it to that point or not. Okay, the next example we're going to do is we're going to find the normal line for the problem 6 that we just did. So we have our point. Now the equation of a normal line is an equation of a line. We're going to go with point slope form again. We're going to need that same point, -2 1/3. That's going to carry over. But the slope of the normal line, if you'll remember, is perpendicular to the slope of the original line. So since the slope of the original line was 1/9, a perpendicular slope is going to be the opposite sign and the reciprocal of the one we got originally. So since we had 1/9, the opposite sign would be -9/1, or just -9. So this equation would be y minus 1/3 equals -9 times x plus 2. And then again, if you wanted to distribute that and add 1/3 to both sides, you would get y equals -9x, and then minus, that'd be 18 plus, -18 plus positive 1/3 would be -17 2/3, or as an improper fraction, that would be -53/3. So for the normal line, it's once you've written the tangent line equation, really all you're doing is changing this slope to the opposite reciprocal and rewriting the equation from there. Alright, next we're going to work on number 11 from your worksheet, which is your homework. Pardon me. Number 11, it says, let f be a function where f of 2 equals 6. That means we have a point 2, 6. Such that for all points x, y on the graph of f, the slope is given by, so the slope, we have an equation for that, which is kind of the same thing as like f prime of x, 2x cubed minus 4x over 4y. Part A says to find the slope of the graph of f at the point where x equals 2. Okay. Then part B says to write an equation for the tangent line of f at x equals 2 and use it to approximate f of 2.2. Okay, so if x is 2, notice if x is 2, then that means that y has to equal 6. So if I want to know the slope here, I'm going to use this slope equation and plug in 2 for x and 6 for y. So 2 times 2 cubed minus 4 times 2 over 4 times 6, which is 16 minus 8 over 24. 8 over 24 is 1/3. So that's the answer for A. Then for B, we are writing the equation for the tangent line. So I have this point, I have this slope, so I'm going to use point slope form. Y minus 6 equals 1/3 times x minus 2. And approximate f of 2.2. So we're going to use this tangent line equation to approximate the value of f of 2.2. That just means I'm going to plug in 2.2 for x and find y. So this is going to be 2.2 minus 2 is 0.2. 2/10 is the same thing as 1/5, so this is 1/3 times 1/5 equals y minus 6. I could add that 6 to both sides, so that's 6 plus 1/15 would be 6 1/15, whereas an improper fraction, that would be y equals 91/15. Okay, now we're going to do number 14 from your worksheet. Okay, our next problem that we're going to do as an example from our homework worksheet is number 14. And it says find the equation of the tangent line, and then it has an s in parentheses, so it could be more than one, where x equals 1 for the equation 2xy squared plus x squared y plus 5x equals 8. Not your simplest equation you to work with. So, to write an equation for a tangent line, we need two things, a point and a slope. Let's get our point first. We know what the x coordinate is, so we're going to plug that in for the x's in the equation and solve for y to see what the y would be that corresponds. 2 times 1y squared plus 1 squared y plus 5 times 1 equals 8. So that's 2y squared plus y plus 5 equals 8. I'm going to get this set equal to 0. So I'm going to subtract 8 from both sides. 2y squared plus y minus 3 equals 0. Now we're going to factor this quadratic trinomial. 2y, y, 3, 1, plus minus. So I have 2y plus 3 equals 0, or y minus 1 equals 0, which makes y equal to negative 3/2, or y equal to 1. So we have 2 points, which means we're going to have two tangent line equations. X being 1 with y of negative 3/2, x being 1, y being 1. Okay, so now we need a slope. How do we find the slope? We are going to take the derivative of the original equation up here, which we're going to have to do using implicit differentiation. I'm going to do that on the next screen. So let me write down the equation again. 2x y squared plus x squared y plus 5x equals 8. So the derivative would be, now here I'm doing a product rule. I've got a 2x times a y squared. So first function, 2x times the derivative of the second function, which would be 2y dy dx, plus second function, y squared, times derivative of the first function, 2, plus, again, another product rule, first function x squared, derivative of the second function, dy dx, plus second function y, times the derivative of the first, 2x, plus the derivative of 5x would be 5, and the derivative of 8 would be 0. So I'm going to simplify this. 4xy dy dx plus 2y squared plus x squared dy dx plus 2xy plus 5 equals 0. Now, we want to get everything with a dy dx on this. Leave it on this side and move everything else over to the opposite side which means the sign will change. We're going to subtract these from both sides of the equation. So, and I'm going to go ahead and factor out the dy dx. So I'm going to say 4xy plus x squared times dy dx equals negative 2y squared minus 2xy minus 5. And now I'm going to divide both sides by that which is in the parentheses. So dy dx will equal negative 2y squared minus 2xy minus 5 over 4xy plus x squared. Okay, that's my derivative. Now, I need to know the slope of each of these two tangent lines. Remember, I had the 2 points. One, negative 3/2, and 1, 1. So the way I get the slopes of each of these is I plug those points into this derivative for x and y. And then that'll give me the slope of each one. I'm going to go to the next screen to do this. This is not the shortest problem we've ever done. So, dy dx such that we are on the point, I'm going to start with the harder one, 1, negative 3/2 is going to equal negative 2. I'm plugging this point into the derivative. Hopefully you're writing this down. Negative 3/2 squared, minus 2 times x of 1, y of negative 3/2, minus 5, all divided by 4 times 1 times negative 3/2 plus 1 squared. So that's going to equal, go back, negative 9/2 plus 3 minus 5 over negative 6 plus 1, which is negative 9/2 minus 4/2 over negative 5, which would be negative 13/2 times negative 1/5 multiplying by the reciprocal with my complex fraction gives me 13/10. So the slope of the first line will be 13/10. So I'll have the equation y plus 3/2 equals 13/10 times x minus 1. There's the answer for the first one. Now, let's find dy dx such that I'm on the point 1, 1. So this will be negative 2 times 1 squared minus 2 times 1 minus 5 over 4 times 1 plus 1 squared. So that's negative 2 minus 5 over 4 plus 1, which is negative 9/5. So this is going to be y minus 1 equals negative 9/5 times x minus 1. And that's the answer for the other tangent line. All right, number 17. Number 17 says find all points where the curve um, 25 x squared plus 16 y squared plus 200 x minus 160 y plus 400 equals 0 has a horizontal tangent line and a vertical tangent line. Okay, well, tangent lines, I'm just looking for the points where these types of tangent lines are going to occur. I'm going to need the derivative to do that. And I'm going to have to take the derivative implicitly since this equation has both x and y's mixed in. So, 50x plus 32y dy dx plus 200 minus 160 dy dx. Shh, Brandon. Shh, quiet, please. All right, equals 0. So everything with the dy dx can stay on this side. Everything else moves to the other side. And I'm going to go ahead and factor those terms that are in front of the dy dx. And divide both sides by that which is in the parentheses. So there's my derivative. Now, vertical tangent and horizontal tangent. What do you know about the slopes? What's the slope of a vertical line? Undefined. Which means that the denominator is equal to 0. What's the slope of a horizontal line? 0. How do you get a slope of 0? When the numerator is equal to 0, the denominator could be anything. So I'm going to say, alright, it's going to have a vertical tangent line when that denominator equals 0. So I'm going to take my 32y minus 160 and set it equal to 0. So if I add 160 to both sides, that gives me 32y equals 160, and then I divide by 32 on both sides, I get y equals 5. Okay, so anywhere y equals 5, I'm going to have a vertical tangent line. Numerator equaling 0 would be negative 50x minus 200 equals 0. Add 200 to both sides, negative 50x equals 200. Divide by negative 50 on both sides, x equals negative 4. Okay? Now, the problem tells you to find the points, not just the x-coordinate or the y-coordinate. So we need to plug these back into the original equation to find the x's and y's that correspond. So, the original equation was 25x squared plus 16y squared plus 200x minus 160y plus 400 equals 0. So if I plug a y equal to 5 in here, then that's going to give me 25x squared plus 200x equals, let's see, these are going to add up to 0. So factor this, 25x times x plus 8. Set each factor equal to 0. That means x equals 0 or x equals negative 8. So I have a vertical tangent line at 0 for x, 5 for y, and negative 8 for x, 5 for y. Now I need to find the horizontal ones. So I'm going to take these for the horizontal are when x equals negative 4. So I'm going to go 25 times negative 4 squared plus 16y squared plus 200 times negative 4 minus 160y plus 400 equals 0. 400 plus 16y squared minus 800 minus 160y plus 400 equals 0. It's going to be 16y squared minus 160y. The rest of that adds to 0. Factor it. Oops, 16y times y minus 10 equals 0. So y equals 0, or y equals 10, which gives me the points -4, 0, and -4, 10 are the points where I have a horizontal tangent line. Okay. The next one we're going to do, it says use an appropriate local linear approximation to estimate the value of the given quantity. And for number 18, they give you the square root of 24. So, first thing you need to do is figure out, well, what is that function we're working with here? F of x equals the square root of x. On number 19, for example, it'd be f of x equals the sine of x. And we need a point. We need a point that is close to 24 for x. So that would be, and one which we actually know the square root of. So 25 is a number close to 24 that I know the square root of. If I put x as 25, then the output for y, whoops, go back, is 5. So now I'm trying to approximate this square root by using this close by point. I'm going to write a tangent line equation in order to do that, so I'm going to need to find the derivative. So I might want to think of f of x as being x to the 1/2 power. That makes f prime of x be 1/2 x to the -1/2, which is the same thing as 1/2 square roots of x. And then f prime of 25, plugging that x coordinate in, will be 1/2 times the square root of 25, which is 1/2 times 5, which is 1/10. So I'd have the equation y minus 5 equals 1/10 times x minus 25. Now that I've written my tangent line equation, I'm going to substitute this 24 in place of the x to get an approximate y value that goes with that. So this would be y equals 1/10 times 24 minus 25 would be -1 plus 5. That means it's -1/10 plus 5, which is 4.9. So that's our approximation based on this tangent line model that we came up with for the nearby point of 25.5. Now we're going to look at the differentials. For differentials, the most important thing that you need to know is that dy equals f prime of x dx. That's the big main idea here with differentials. Basically, differentials just tells you that these dy and dx actually do mean something independently, and it kind of steps us into differential equations, which is calculus 4. But we're not going to do anything that hard today. These are actually really easy. Let's take a look at number 22. It says find dy, and they give you y equals 5 times the tangent of x. So y prime would be equal to 5 times secant squared of x, and so then the f prime of x dx means dy equals 5 secant squared of x, and we put the dx at the end, and that's the answer. So even though these problems sound kind of funky, they're really easy to do. Alright, hopefully y'all have a good understanding of local linearity and the easy concept of differentials. Good luck on your homework worksheet.